So number one, we want to find x, and what side is x? Is it opposite, adjacent, or hypotenuse? Adjacent, okay? And we know that this side is 12, and what does that side represent? Hypotenuse. So there are two trig functions that you could pick. You could either pick cosine or you could pick secant. I'm going to use cosine. So cosine of my angle is equal to adjacent over hypotenuse. Everyone agree with that?
Yeah.
Okay. So in order to solve that, I'm going to multiply both sides by 12. So then I've got x by itself, and I can type that in my calculator. And so it's 12 times the cosine of 37 degrees. And that side's about 9.58-ish. As far as how many decimal places, keep a couple. You know, in this case, it wasn't, the problem didn't have decimals. You should try to be consistent, but I wouldn't just round it off to the nearest whole number. That's not very accurate. So I'd say that it's about 9.58. Okay. So questions about that one? Okay. So it looks like the big question's about number 2. Right?
Yes. Number 2.
Okay.
Are you recording this? It's recorded.
Yes, the whole time. Okay, so number 2, in relation to this angle, I know the opposite side. I want to know the hypotenuse.
Tangent.
So,
Tangent 69.
sine would work, and so would cosecant. They both have their advantages. So here's the deal. If I use sine, the advantage of sine is that it's a button on my calculator. Okay? And did anybody try it with cosecant?
Well, we didn't.
Well, there's no function for it, right?
No. So we'll do that in a minute, and I'll show you how you can type it in your calculator. Because you can still type it in.
It's complicated.
It's just a little, it's not complicated. We just have to kind of remember some of the definitions. But we'll just use sine first. So I know the sine of my angle is opposite over hypotenuse.
Yeah.
Okay. There are 2 ways you could go about this. If x is in the denominator, you could flip both sides. But maybe an easier way to think of it is, think back to 8th grade, middle school, when you're solving percent problems. Their ratios and proportions, you can do cross products. Okay? So, because this would be like over 1, right?
Yeah.
Cross products are equal to each other. So x times the sine of 21 degrees. Whoops. So x times the sine of 21 degrees would equal 10 times 1, which is just 10. And we want to get x by itself. So to get x by itself, I'm going to divide both sides by the sine of 21 degrees. Okay, so the sine of 21 divided by the sine of 21, x is by itself now because that canceled out. And this is what I type in my calculator. So 10 divided by the sine, 21 degrees,
Dang, that's pretty good.
bam, 27.9. So the hypotenuse is about 27.9. And there we go. Make sense?
Yes.
Okay, there are other ways to go about it, but that's one of the ways to do it. Now, here's the problem I see when people use a trig function that has x in the bottom of a fraction is that people probably need to put their phone away. But then the other problem would be they make algebra errors, okay, when they're solving. If we do the same problem, but we use a different trig function, the algebra is easier, but the calculator is the problem. So let's see, this was 21. Which one was 10? This one, yeah. Okay. What are you doing? It's 10.9.2.39. Okay, so let's say we use a different trig function so x is on top. Okay, so I'm going to use cosecant because the definition of cosecant is that it is hypotenuse over opposite. Does that make sense? Okay. How would I get x alone here? How would I get rid of that 10 down on the bottom? I would multiply by 10. Okay. So now x is alone. X is equal to 10 times the cosecant of 21 degrees. Now we do have a problem because this, the cosecant of 21 degrees, we don't have a button for that on our calculator, but we do know something about cosecant. Which function is it the reciprocal of? Sine. And what's reciprocal mean?
Flipping it over.
Flip it over so that, so cosecant is the same thing as 1 divided by the sine. Because reciprocal means 1 over, right? When we say flip it over, that's what it means, okay? And so times 10. So really, in my calculator, I would type in 10 divided by the sine of 21 degrees. That's the same thing we had to type in doing it the other way. When it comes down to it, you're still going to enter the same thing in the calculator, even if you use a different trig function. Does that make sense? So it doesn't matter which way you do it. This way, people make fewer algebra errors, but where they make mistakes is actually entering it in the calculator. So if you stick with sine, cosine, and tangent, there just might be that if x is on the bottom, you have to make sure that you watch your algebra. Okay. So other questions? Okay, there's one other type of problem. One of them might be finding sides. If you're finding lengths of sides, you use one of the regular trig functions. But here's a problem where maybe they give us sides. Let's look at kind of a famous triangle. 3, 4, what's this side? Okay, 3, 4, 5. Pythagorean triple, right?
Yeah.
What I want to know, this side, or this angle, sorry. I want to know the angle. Kind of, yeah. So you need to pick 2 sides. If they give you 2, you're going to use those 2, but here you have your choice. What 2 sides do you want to pick?
4, 5.
Okay, so I hear a few things. Somebody said, I want to use opposite, okay? And just pick any other side you want to use. Okay? We're going to pick those 2. Someone else might have picked 2 different ones, but you pick 2. And then we're going to write a trig function using those sides. So do you agree we could use sine? Okay, so sine of my angle is opposite over hypotenuse. Okay, now this time I'm not solving for a missing side. I'm trying to solve for theta. I want to know how big this angle is. And this is where I use the inverse trig functions. So the way that I would find theta is I'm going to take the inverse sine of that trig function. Inverse trig functions find angles. That's what they do. They tell you angles. So if I type that in my calculator, it's probably not a very nice number. Okay? 30 something. So inverse sine, oops, there we go. So inverse sine of 3/5 is about 36.8 degrees, or I could say in degrees, minutes, and seconds. Remember how we worked with some things in degrees, minutes, and seconds? There we go. And we had, in the angle menu, we had our degrees and minutes, and we have seconds over here. This button down here, number 4, where it says, has a little arrow and then it says DMS, that says change my angle to degrees, minutes, and seconds. It will put it into degrees, minutes, and seconds for you. So I can, it's not cooperating. So second angle, I'm going to pick number 4. It's going to say take that answer, put it in degrees, minutes, and seconds. So our angle is about 36 degrees, 52 minutes, 11 seconds. Okay. If it asks for your angle in degrees, minutes, and seconds, then you're going to give this. If it doesn't ask, it's up to you. You could put either one. So it's around 36.87-ish degrees, or 36 minutes, or degrees, 52 minutes, 11 seconds. But that's what these ones up here are: inverse sine, inverse cosine, inverse tangent, or inverse trig functions are going to tell us the angles that we are looking for.
Can you go back to the other one?
Sure.
Yeah.
So here, so we got 36.87-ish degrees, approximately, which was about 36 degrees, 2 minutes, 11 seconds. So questions at all? Okay, so here's what I'm going to ask you to do for your assignment. I do want you to look at this over the weekend, and there are some problems I want you to do to practice. I'm going to give you odds because I want you to be able to check your answers in the back of the book. It doesn't do you any good to like do a bunch of them and have them be wrong. Okay, so page 73, 74. We're going to look at 9 through 13 odd. And then 19 through 29 odd. So it's really like 8 whole problems. On 19, they just give you some letters, and I want you to understand how they do this. So standard notation is that the right angle is angle C, because the hypotenuse is what we call side C, right? For a squared plus b squared is c squared. The other ones, it doesn't matter which one's a and b, but wherever angle b is, across from that is side b. And wherever angle a is, across from that is side a. Okay, so for the entire class, everything, that's how the notation's going to work. Okay, so they don't give you pictures on number 19. They just say, oh, angle a is this, find side a. They're across from each other. So questions at all? Okay. Well, then have a nice weekend and enjoy St. Patrick's Day. It's my St. Patty's Day. It's my holiday. Sure. Got the red hair and everything. Used to be Patty O'Flynn. Doesn't get much more Irish than that. I guess I better stop the recording before it fills up my hard drive.
Oh my god.